All right. So today, the last news section of the year, and then we'll do some other stuff. We'll do some reviewing. Maybe do some trig. We'll maybe do some regular polygon areas and stuff that you guys struggled on a little bit this year. We'll go back and hit a little bit of that before we crank out a final test in here. But we'll have a final project to do too. So we'll kind of get all that ready next week. Okay, so here we go. Tree diagrams. Tree diagrams can help us figure out certain information. So look at this problem. A college reported the following based on their graduation data. 70% of the freshmen had attended public school. 60% of the freshmen who had attended public school graduated within 5 years. 80% of the other freshmen graduated within 5 years. From all that data, I should be able to know what percent of the freshmen graduated in 5 years. So let's figure that out. Now, you got the public school kids, and then you got the private school kids, which are not public school. Now, of those that attended public school, 60% graduated on time within 5 years. 40% of them either dropped out of college or went a long time to college. We got a 70% here. Okay? Of the non-public schools, 80% of the other freshmen, that's non-public school kids, because they're 30% down here. Because if this is 70, this is 30. 80% of the other ones graduated within 5 years. So then 20% of the others, not so good. So if we multiply across, this is 42% of the kids graduated on time. 28% of the kids, not so much. Here, 24% or 0.24 were good. The other 6% were not. I kind of combined my smiley face with a 0.6 there. I wondered what was going on. All right. That's the not so good. So we're wondering which ones are the good ones. Here and here. What do they add up to? Well, that's 66%. So that's using tree diagrams to figure things out. Now, a couple of questions are worded, well, kind of like that. Some are worded a little differently. So you'll see what I mean here. So let's work our way through it. All right. So a jar contains 12 large red marbles, 5 small red marbles, 9 large blue marbles, 7 small blue marbles. So we can make a little diagram here. You got large and small. You got blue and red. You got a total and a total. Okay? So large blue, there's 12. Small red, there's 5. Oh, large red, there's 12. How was that?
Not good. See you in the morning.
I'll see you in the morning. We'll maybe go, we got to go over logarithms before you start it the next time.
Please tell me how.
Yes, I will show you how to do some of those logarithm problems. Because we'll look at just at one of your, can you go back to your old practice tests?
Yes, you can.
Okay, so we'll go back to an old practice test and go through logarithms.
All right.
So, totals. If we add up, there's 21 large marbles. There's 12 small marbles. There's 16 blue marbles. There's 17 red marbles. Now, we're wondering, What's bigger? The probability as if they start as small marbles, then they're blue, or if they start as blue marbles, then they're small. So PBS is of the small marbles, of the 12 small marbles, how many of them are blue? 7 of the 12. Of the blue marbles, how many are small? Well, blue, there's 16 total blue marbles. How many of them are small? 7. What's a bigger number? 7/12 or 7/16? 7/12 is bigger. So BS is bigger. So that's this one. 7/12 is bigger than 7/16. Okay? All right. The next one, the pet one. And I don't like this pet one that much, but this is how you do it. I think the wording is just so hard to work through that it's like they're asking the exact same question as what they have written here. And that's why I don't like it so much, but here we go. 41% of the people who've had a pet, 41% have a pet now and have had a pet. 87% have had a pet sometime in their life. The probability that the respondent has a pet given that the respondent has had a pet. Okay? So what we got going on here is yes to pet or no to pet. And still has it or no more. And if they don't have a pet, that's just nothing because they can't still have a pet if they never had a pet. Okay? So this is 87% of the people. Now, 41% have a pet now and have had a pet. Okay? So this one is 41% over here. What we're looking for is this number here. Okay? And that's kind of hard to decipher through here the way they have it written. But of the 87%, because 13% have never had a pet, of the 87% that have had a pet, 41% of them have a pet and have had a pet that still have a pet. So this times this equals this. So we got to figure out what this is. So 0.87 times what equals 0.41? We'll figure this out. What do we do to each side? Divide by 0.87. Okay, so what's 0.41 divided by 0.87? 0.47. Okay, 0.47. Again, that's kind of an ugly problem because of the way it's written. This next one is so much easier to read. Okay, library books. So you have fiction and you have nonfiction, and you have in bad shape, and then you have in good shape. In bad shape, in good shape. So 10% of the fiction books are worn and need replacement. So 10% of them are in bad shape. 20% of the nonfiction books are in bad shape. Now, the library's holdings are 30% fiction and 70% nonfiction. How many books are worn and need replacement? Well, if we multiply across, 30% times 10% is just 3% of the books. And 70% of 20% is just 14% of the books. So if you take these are worn and these are worn, you don't even need to know these. We could find this. This would be 90% and this would be 80%. And we could find these numbers, but they aren't really relevant to what we're talking about. We're just talking about the bad ones. If we add these up, they add up to 17% or 0.17 if we're told to write as a decimal. And the last one. In a research study, you had drugs A, B, and placebo. A, B, and placebo. 1/3 got A, 1/3 got B, and 1/3 got the placebo. Out of all the volunteers, 14% got better from drug A. So 14% out of the whole thing, not just of these guys. We don't know what goes there. Okay? So 14%, we're good there. On B, the ones that are good equals 9% of the total people. And the placebo equals 6% of the total people. So if it's of the total people, okay, that number goes last, such as 3% of all the books are worn and need replacement. Here, 14% of all the books. So 14% of all the people, okay? So now, so what we do is we have to figure out what is the conditional probability of people getting better if they had the placebo. So 1/3 of what equals 6%? How do I get rid of the 1/3? Multiply by 3. 6% times 3 is 18%. That's how many got better. So this last area is out of all the people. The first area is of that particular thing. Okay? But like I said, this one I just don't like the wording of. But you can muddle through it. Okay? There's only a whopping 4 problems on today's assignment. Tomorrow we will do a review. Monday is a practice test. Tuesday is the test. Because I don't like giving Monday tests on right after a weekend. So Monday you can kind of wrap your brains around a little better to get ready for a Tuesday test. So here we go. If any of you are behind on quizzes or anything like that, today would be a good time to catch up. Joe, did you come in and get caught up? Yeah. Okay. So here we go. Let me put it out there.